Hello students, today we are going to learn some theorems. Now first theorem is perpendicular bisector theorem. Now write down its statement. Every point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. Now this is the statement. Now we have given a figure. AB is a segment. Its perpendicular bisector L is its perpendicular bisector. Now we take any point, suppose P point here. Now draw AP and BP. Now let us see here, every point on the perpendicular bisector of a segment is equidistant from the endpoints. Now let us see how we can solve this theorem. Now first we have given line L is the perpendicular bisector of segment AB. Line L is the perpendicular bisector of segment AB at point M. This is given. Now we have to prove AP is equal to BP. And also we have given P is point on line L. AP is equal to BP. Now here we have to show AP is equal to BP. Now for this, draw segment AP and segment BP. Now in triangle PMA and triangle PMB, this is common side, this is given, and this angle is of 90 degrees. Therefore, by SAS test, these two triangles are congruent, and corresponding sides of congruent triangles are congruent. Therefore, AP is equal to BP. This is the proof. Now write down here, given line L is the perpendicular bisector of segment. Line L is the perpendicular bisector of segment AB at point M, at point M. This is given. To prove, now here we have to prove if PA is equal to PB. PA is equal to PB. That is, if this is any point is equidistant from the endpoints. If PA is equal to PB. Construction. Draw segment AP and segment BP. Draw segment AP and segment BP. This is construction. Now prove. Now write down in triangle PMA, and triangle PMB in these two triangles. Now segment PM congruent to segment PM, first two are equal, therefore segment PM congruent to segment PM. This is common side. Angle PMA congruent to angle PMB. Angle PMA congruent to angle PMB. Now what is the result? Each of 90 degree. Each of 90 degree. And segment AM congruent to segment BM. This is we have given. Therefore, by side angle side test, that is SAS test, therefore by SAS test of congruency, these two triangles are congruent. Triangle PMA congruent to triangle PMB. Now we know that corresponding sides of congruent triangles are congruent, therefore PA congruent to segment PB. Therefore segment PA congruent to segment PB. Write down in bracket corresponding sides of congruent triangle CSCT, corresponding sides of congruent triangle. That is, these two segments are congruent, therefore we can write this as PA is equal to PB. PA is equal to PB. This is the proof. Now number 2, second. Angle bisector theorem. Number 2, angle bisector theorem. Angle bisector theorem. Now first write down here statement. Every point on the bisector bisector of an angle is equidistant from the sides of the angle. The sides of the angle. Now first draw the figure. We have given angle PQR. QS is its angle bisector. Or QA is its angle bisector. QS. Now we have to show this point is at equidistant from these two sides. Suppose this point is A, this point B, this point C. This is right angle. Now let us see here. Every point on the bisector of an angle, every point on the bisector of an angle is equidistant from the sides of the angle. Every point is equidistant from the sides of the angle. Now here, first we write given ray QS is the bisector of angle PQR. This is given, and A is the point on ray QS. This is given. To prove, we have to prove AB is equal to AC. That is, this is equidistant. AB is equal to AC. Now prove. Now in triangle ABQ and triangle ACQ, in these two triangles, these angles are congruent. This is also congruent. We have given, and this is common side. Therefore, by side angle test, SAA test, these two triangles are congruent. And we know that corresponding sides of congruent triangles are congruent, therefore AB is equal to AC. Now write down, first write down given. Ray QS is the bisector of angle PQR. Point A is any point on ray QS. This is given. To prove, we have to prove AB is equal to AC, that is equidistant. AB is equal to AC. Now prove. Now here, in triangle ABQ and triangle ACQ, in triangle ABQ and triangle ACQ, angle ABQ congruent to angle ACQ. Angle ABQ congruent to angle ACQ, each of 90 degree. These two are congruent. Angle AQB congruent to angle AQC. This is given. That is, this is bisector. Therefore, these two are congruent. And QA segment QA third first congruent to segment QA. This is common side. Therefore, by side angle SAA test, these two triangles are congruent. Triangle ABQ congruent to triangle ACQ. Now we know that these two triangles are congruent, therefore their corresponding sides also congruent. That is, therefore side AB, congruent to side AC. Write down corresponding sides of congruent triangles. Therefore, these two sides are congruent, therefore they are equal. Therefore, AB is equal to AC. This is the proof. Number 3. Now theorem number 3. Properties of inequalities. Properties of inequalities of sides. Inequalities of sides and angles of a triangle. Now here, theorem. Now first write down statement. If two sides of a triangle, are unequal, then the angle opposite to the greater side is greater than angle opposite to the smaller side. This is the statement. Now here draw the figure. First we draw the figure. x, y, z, p, these two are congruent. Now here, if two sides of a triangle are unequal. Now here, xy and xz, these two are unequal. That is, they are not equal. Then the angle opposite to the greater side. Now which side is greater? Xz is greater than xy. Angle opposite to greater side xz, its opposite side is this angle y. Is greater than angle opposite to smaller side. Now opposite of this side is angle is z. Therefore angle y is greater than angle z. We have to show this. Now how we can solve this? First write down given in triangle XYZ. XY segment or side XY is greater than side XZ greater than side XY. This side is greater. Therefore, and we have to prove angle XYZ greater than angle XZY. This angle is greater than this angle. Now for this construction, take point P on side XZ such that XY is equal to XP. These two are congruent, or XY congruent to XP. This is the construction. Now proof. Now in proof, in triangle XYP, these two are congruent, therefore these two angles are congruent. Therefore, now this angle is greater than this angle. Angle XPY is an exterior angle of triangle YPZ. Therefore, these are called remote interior angle theorem. By remote interior angle theorem, this angle is greater than this angle. Also, this angle is greater than this angle. By using this, we can prove this our given. Write down given in triangle XYZ. In triangle XYZ, side XZ is greater than side XY. To prove, now we have to prove angle XYZ greater than angle XZY. Construction. Now take point P